Hi. To find a straightforward comparison between the two groups of data, we routinely perform t-test. The t-test calculates the difference between the means of two groups and determines whether this difference is statistically significant or not. If, for example, on this spreadsheet we had more than two columns, for example, one was here, maybe we had the fourth one, and so on, we would not use t-test. Rather, we would be using one-way ANOVA, because one-way ANOVA compares multiple groups simultaneously. In t-test, we normally have two columns. Now, in order to perform a t-test, open your Excel spreadsheet and ensure that your data is arranged in two columns, one for control and the other for the treated group. In this example, each group has 9 values. Since our required p-value is less than 0.05, so we'll write that here. This required p-value could be different. That depends on the nature of your experiment and the level of significance that you require. Next, in the formula bar, press the FX button to open the insert function library. It offers you different functions. You have to select the appropriate one. For example, t-test, sum, average, etc. Here we are interested in t-test, so we will click that and press OK. Here you can see another dialog box open, which is function arguments. Here in array 1 and array 2, you have to enter the range of cells that you are interested in. This is one of our range of cells. So the array 1 is basically your this data starting from 10 to 6, all these digits basically. So while having the cursor ticking here, just select this data from 10 to 6. There you go. Now just click this array 2 here. Now your cursor is on array 2. And this is your array 2 in the data. So select from 9 all the way down to 7, like you did previously. Now your both array 1 and array 2 fields are done. Next is to fill tails and type of the test. Bring the cursor here. It gives you some information. Specifies the number of distributions tails to return. One tail distribution is 1. Two-tail distribution is 2. Because I'm interested in two-tail distribution, so I will type 2 here. Come down to the next one, which is type. Paired is 1. So if we needed paired t-test, type 1. For two sample equal variance, write 2. In order to do two sample unequal variance, you will have to write 3 here. So for the kind of data I have, I will write 2 here and 3 here, and then hit OK. There you go. This is your calculated p-value. Now at this point you have obtained the desired p-value, which is the information you were looking for. However, if you want to further utilize Excel to assist you in making this decision, you may apply a formula. By applying that formula, you will let Excel automatically determine whether your calculated p-value is less than 0.05 or greater than 0.05. I'll show you this formula in a bit. By doing this additional step, the Excel will provide you an automated indication of whether the calculated result is to be considered significant or non-significant. Now, in order to perform this, we use if function. This if function is applied commonly in Excel to allow Excel make a decision for you. So in our case, this if function will automatically evaluate the decision on our calculated p-value. Now I'm going to complete this formula. G6 is less than F4. comma, significant, comma, NS, which is for non-significant, and brackets closed. Now hit enter. So our p-value in this case is non-significant, means it is greater than 0.05. Now this decision is offered to you by the Excel using if function. I may write here, result is non-significant. Now in this formula, the G6 represents the calculated p-value, which is in the G6 column, and F4 represents the required p-value, which is present in the F4 column. Now let's play around with this data, the treated group, and see whether this result changes or not. For example, I change here. Instead of 9, I replace with 6. Instead of 14 here, I type 8, and it becomes significant here. So if we had this data, the result would be significant, means our alpha or the p-value is less than 0.05. Now this is it for today. In the coming lectures, we will see how to calculate standard deviation and SEM in Excel. We will also see how Excel computes one-way ANOVA for us.